Today we are going to explore why we use PWM, that is pulse width modulation, to control the brightness of an LED instead of directly using a potentiometer. In this setup, I have a 10K potentiometer controlling the brightness of the red LED. Meanwhile, for the blue LED, we first read the potentiometer output using A7 pin and then use the map function to control the brightness via D9 pin. Additionally, I have a voltmeter displaying the potentiometer's output. Now let's see how the LED behaves as I turn the potentiometer knob. As I increase the voltage, the blue LED turns on at around 0.2 to 0.4 volt, but the red LED is still off. As I continue increasing the voltage, the red LED turns on at approximately 1.6 volt. Increasing the voltage further, you can see both the LEDs gradually getting brighter. At around 4.9 volt, which is the maximum output from this setup, both LEDs are at their full brightness. Now let's reduce the voltage. The red LED dims quickly and turns off at around 1.4 volt. However, the blue LED remains controllable and turns off at around 0.02 volt. So, from this experiment, we can see that using PWM to control LED brightness gives us a wider range of control, smooth adjustment, better precision. On the other hand, directly using the potentiometer's output limit control, making fine adjustment more difficult. Thanks for watching. If you enjoyed this video, please subscribe for more. See you in the next one.